So here what we're looking at is chapter 8, which we're going to see expressions with exponents in it, and it'll ask us to simplify the expression to make it more simple. So there are some rules that will help us do that simplifying. Here they are on the left. If these don't appear on the note sheet that you will get or that you have for your final, you might want to put some of these down. So simplify, your answer should contain only positive exponents. By the way, what's the exponent on this n right here? It's a 1. If you don't see an exponent, it is a 1. So we can rewrite this as there are 4 things being multiplied together. 2 is getting multiplied with n to the 1, which is getting multiplied with 4, which is getting multiplied by n squared. So I'm going to put my coefficients, my numbers out in front, together. There's 2 more things that are getting multiplied together here. It's n to the 1 and times n to the 2. So just rearrange things. Well, 2 times 4 is 8. And now I have over here n to the 1 times n to the 2. When I'm multiplying values together that have the same base, I take the exponents and I add them. So that would be n to the 3. 1 plus 2 is 3. So A is the correct answer here. Similarly, in number 2, we can go 4 times 2 times 4. I just took all 3 coefficients and multiplied them together. And then I have b to the 1 times b to the 2 times b to the 1. So 4 times 2 times 4 is 32. And then here we'll add the exponents together. So we're multiplying the coefficients together because that's what it says to do. And then our rules say that you add the exponents when you're multiplying the same bases together. So 1 plus 2 plus 1 is 4. So I have 32 b to the 4. That's option or letter B. Alright. Now we're going to start seeing some negative exponents. And back in the day, I'd call those traders. In fact, there's a lot going on here looking at number, yeah, we'll do, sure, this one. So one task that we're doing here is sprinkling. If you see an exponent outside of the parentheses, get sprinkled to the other values. So 3 is going to get raised to the negative 3, and x to the 4th is going to get raised to the negative 3. So this is going to become 3 to the 3rd power. 3 to the negative 3rd power, because it's a negative 3 exponent that we're putting in there. And then x to the, so now when I have a power raised to another power, what do? Power to a power, we take those 2 powers and we multiply them together. So 4 times negative 3 is negative 12. Now remember, our direction said only positive exponents. Negative exponents are like traders. They're not showing their true colors. And when I'm talking about true colors, I'm talking about a fraction and what's on the top or on the numerator and what's on the bottom or in the denominator. I don't see a fraction right now, but of course we could by dividing everything by 1. These 2 values are on top right now, but they are traders. They have a negative exponent. They actually belong on the bottom. If you see some number with a negative exponent and it's on top of the fraction like this is right here, we move it to the bottom, and once we move it, once we identify something as a trader because it has a negative exponent, we move it to the opposite side of the fraction bar, but we make that exponent now become positive. So this thing actually belongs to the bottom, as does this, because they're both on the top and they both have negative exponents right now. So I'll take this, move it to the bottom, and make its exponent become positive. And same with the x. I'll move it to the bottom, but I'll make its exponent become positive. Well, there's nothing left on top. When we talk multiplication or division, we need to have a 1 there as a placeholder. So there's a 1 on the top. Now, as I look at the answers, shoot, I don't see any of them that match this. I mean, B or D are our closest options. So what is 3 to the 3rd? That means 3 times 3 times 3, which is 27. So this is the correct answer. 27 times x to the 12 is dividing the 1. Let's try that one on your own. Here, something to think about is anything to the power of 0 is just 1. So we can really simplify this as m to the negative 2 times 4 times, or divided by 4 times 1. M to the negative 2 divided by 4. Now we don't want negative exponents, so this thing's a traitor, so it's actually going down to the bottom. That 4 doesn't have a negative exponent, so it just stays where it is. It stays on the bottom, and then we get a 1 there. Let's try number 8. So let's sprinkle first. So we get x to the negative 5, I'm just copying that down, times y squared, times 2 to the 5th, times x to the 5th. Alrighty. Now we have, this is all getting multiplied together. We have x to the negative 5 times x to the positive 5. So essentially we have this going on right here, with the same bases being multiplied together. So we add the exponents together. So when I look at the x to the negative 5 and the x to the positive 5, I add those exponents and we actually get x to the 0. So these essentially cancel each other out. So then to simplify this, 2 to the 5th is 32, and y squared is y squared. So there we go. These guys again undo each other. You could say, well, hey, isn't this a traitor? Doesn't that go to the bottom? So I got 32y squared. And then if we go back to this, we're saying that that's actually should be on the bottom. And this guy has a positive exponent, so it stays where it is on top. Again, don't these things undo each other or become 1? Yes, they do. Ooh, number 10 looks great. That looks like a lot of fun. So let's sprinkle first. I'm going to do this down below. If you need to use scratch paper, do it. So we get 2 squared, and we get n to the negative 8 times n to the 5 times n to the negative 4. There's at least 2 right moves you can make from here, and it's really up to you how you want to do that. So you could identify the traitors and move them to the bottom, or all of these n's are getting multiplied together. They have the same base, so we can just add the exponents right now as it is. Add negative 8 and 5 and negative 4. And so we get n to the power of negative 7. And by the way, 2 squared is 4. So now we've simplified this quite a bit. This is great, except for we can't have negative exponents in our answer. So that thing is a traitor. The n is a traitor. The 4 is not a traitor. It's got a positive exponent of 1 there, right? You don't have to actually put that in, but that's what an exponent is. But this is on top, and it's a traitor. It belongs on the bottom because of the negative exponent. So move it and make the exponent positive. That is what, letter D? Yeah? Good? Cool. These are all too easy for you. Number 14. Here, why I especially wanted to show you this is because we're going to have a traitor and a battle. Actually, we're not going to have a battle. We'll have to do a battle here in a little bit. There's a traitor. It needs to go to the top and have its exponent become positive. This is a traitor. It needs to go to the bottom. So sometimes the negative exponents or the traitors are on the bottom, and when they're on the bottom, they have to go to the top. So we get 2u to the 1. Right there is u to the 1. And then this traitor is going up, and its exponent of negative 1 that identifies it as traitor becomes positive once we move it. Just like this exponent becomes positive once we move it. Don't forget the 2 on the bottom there. So now let's try to simplify this from here. 2 divided by 2 is 1. We add the exponents here. So you get u to the 2 over v to the 4. We can't simplify that any further. that is the final answer. Gotta find a battle here for us to do. Remember what battles mean? You do? Oh, that's good. So, we'll get a battle on both of these. I'm going to do 16. So we have 2v on top. I better show it down below. I think with a pencil you can write in here, but again, use scratch paper if you want to. We got to sprinkle this exponent in 4 sprinkles. Let me show that better. Sprinkle, 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 sprinkle. So u to the 8 times 2 to the 4th times u to the 4th times v to the 4th. So on the bottom, we can clean this up a little bit. It's u to the 12th. So 2u to the 12, v to the 4. On the top, we've got, should have done this in a different color. Put an equal sign there. So we see our 2 different steps. On the top, we've got 2v. Okay. So these 2's are going to cancel out, become 1. Now we have v to the 1 divided by v to the 4th. Now if the variables are on the same side of the fraction bar and they're being multiplied together, we add the exponents. Here, they're being divided. They're on opposite sides of the fraction bar, so we're dividing. Now, in this case, we subtract the exponents, or I like to think of it as a battle. The v's on the top are battling the v's on the bottom, and so each v on top takes out a v on the bottom. When I'm talking about the number of v's, or each v taking out the one of the other, I'm looking at the exponents. There is 1v being multiplied. Because of that, the exponent, there's 1v on the top, and there's 4 v's being multiplied together on the bottom, right? Because isn't v to the 4th? I'm going to actually kind of zoom in, not literally, but really focus on this battle at hand right here. That means v times just v on the top, but v to the 4th means v times v times v times v. And just like these 2's can cancel out, a v on the top divides with a v on the bottom to become 1, or to like cancel. So what we're left with is v to the 3rd on the bottom. So on the top we have a 1. The number there got canceled out, or 2 divided by 2 is also 1. So there's nothing but a 1 on top. There's a u to the 12th on the bottom, and one of these got eliminated by the v on the top, so there's v to the 3rd on the bottom. Is that one of our answers? Oh, Mr. P made a mistake, right? That's how it's kind of about multiple choice. You fix things. So going from this step to that step, I made a big mistake. I forgot to actually take 2 to the 4th, and I just brought a 2 along for the ride. 2 to the 4th is 16. 2, so here we actually have a 2 over 16, which is the same as 1 over 8. Or if we talk about battling, I've got 2 to the power of 1 here, and this is 2 to the power of 4. So these have the same bases on the top and on the bottom. The 2's are battling. One of the 2's on the top takes out one of the 2's on the bottom. So this actually becomes, you could think of it as this way. I'm not actually writing the answer right there, but on the bottom I could think I have 2 to the 3rd because of one of these got taken out by one of those. Guess what 2 to the 3rd is, folks? 8. Bam. And why I showed you 2 different ways of doing that, you can either actually calculate what those values are, raise that exponent, or you can battle. What's cool about simplifying these, folks, is that there's many ways to do it. In the end, there is one right answer that's most simplified. But there's a few different ways to do it, so you can kind of just find your own rhythm of how you solve these.